Okay, so that's problematic. Hopefully this one works, and it'll be sound. All right, so picking up where we left off here, we just computed this line integral over f, and now we're going to look at directional line integrals. So if we're going in the x direction only, then f is just the m component. And when you do the integral, all you pick up is of this guy, which turns out to be this. And so if we go in the y direction, then the curve only has a y component, so f dot dr is just that. And similarly, if we're just going the z direction, we have p equals this thing, right? And when you unravel all that, it's just no drama to do. The first integral becomes m evaluated at g hk times g prime of t dt. And here t runs from a to b along the parametric interval. The second one becomes n of GHK h prime of t dt. And the third one becomes p of GHK k prime of t dt. And so if you add all these up, put them together, you get m dx plus n dy plus p dz. And that equals the entire integral. And really what we're doing here is computing work. Right? That's why it's directional. We're computing work done by the force, this vector field, and moving an object along C, like gravity, electricity, water. Okay. And so to define this properly, so we let C be a smooth curve, meaning its derivatives are well defined. And let F be a continuous force on C. Then the work done moving an object from A, which is R of A, to B, which is R of B, is, it's the same integral we've been computing. And this is A to B, f of r dotted with dr dt dt. Okay, so it's the same integral, and like Calc 2, the same integral does a lot of things, right? We compute work. You can also compute flow. called the flow integral. And if A equals B, in other words, it's a closed loop or a closed flow, let's just call it circulation. Okay. So let's do an example here. Find the circulation of the field F, which is x minus yi plus xj around the unit circle. Okay. All right, well, our C is the unit circle, which is parametrized by, you can do it a lot of ways. So we're going to go cosine ti plus sine tj, and t goes from 0 to 2 pi. This just puts us on the circle going counterclockwise from 0 to 2 pi. So it's just like above, we compute f of rt, which is f of cos t sine t, and that turns out to be x minus y, so cosine t minus sine t I plus xj, which is cosine t j on 2 dr dt is minus sine t I plus cosine t j. And when you dot these two, so 3 f dot dr, we get what? We get minus sine t cos t plus sine squared t plus cosine squared t, which is 1 minus sine t cos t. And so we now integrate. T goes from 0 to 2 pi. This guy, which after a u substitution, you get 2 pi. All right, so that's part 2 of part 1. And this is the video for, what date is this? For 11/5. So this is, let me get here. This is the end of video 24. There were 2 parts because of my sound issues, and this is for 11/5. So video 25 is going to be this section, part 2, sorry. We'll pick up here when we start talking about flux. And so yeah, video 23 is in 2 pieces, one of which, well maybe both of which, but one of which doesn't have any sound. And hopefully I'll get the sound thing worked out before I make video 25, which is 16.2 part 2. While I got you here, let me write down the homework. This is the second part of homework 12, section 16.2, 4, 10, 16, 19, 25, and 29. So I'm thinking 16.1 and 16.2 will be the only two sections for this homework. All right.